Hi, my name is Amanda, and today I'm going to talk to you about your experiment, acid-base titration. In this experiment, you'll be creating titration curves for various acid-base combinations. You'll be using the Logger Pro software, so you'll click on the Logger Pro icon on the desktop and load up the Logger Pro program. You're going to need to open a particular file for this experiment, so to do that, click on File, then click Open. Click on the folder Chemistry with Vernier, and you'll see a list of different experiments. The one we want is for acid-base titration, and it's the one called 24A acid-base titration. So load that program, and you should see a display that looks like this. The setup that you'll be using for your experiment is shown here. There's various pieces of equipment that you'll be working with simultaneously. The first item that you'll be using is a pH meter. This pH meter is connected via USB to the computer, so it will take pH measurements in real time and record them in the Logger Pro software. You'll also have a beaker containing your acid, and in one of your steps it calls to dilute this acid with distilled water. You'll also have a stir bar, which works in conjunction with a stir plate that will allow you to stir your solution on its own without you having to manually stir it. And then we also have a burette, which will hold the titrant for your solution. So in this particular case, we have sodium hydroxide in our burette, and we are titrating the hydrochloric acid solution that's in this beaker. So before you actually start the experiment, you need to calibrate the pH meter. You'll follow the instructions that are described in your lab manual, and your TA will also provide you with 2 buffers to calibrate the pH meter. So just sort of follow those instructions, and then you're ready to go for the rest of the experiment. When you set everything up for your first titration, there's a couple of things that you want to note. First of all, the pH meter is a very sensitive instrument. If it is left out of the solution at any point, or it hits the stir bar, let's say, in the solution, then both of these cases can damage the pH electrode. So you want to handle it carefully when you are moving things around or switching out samples or anything like that. The stir bar and the pH meter should be far enough from each other that the stir bar is not going to hit the pH electrode. And the stir bar should also be spinning kind of on a medium setting on your stir plate, just enough so that it's mixing the solution, but that it's not over mixing it and causing your solution to splash out. With your pH meter, you want the electrode to sit all the way in your solution. You don't want it to hit the bottom of the beaker or the side, but you want it sort of surrounded by your solution. And the burette you also want to position so that it's suspended over the solution, so that when you are titrating, the solution in your burette is coming out and right into the solution and not hitting the wall of the beaker. So you will fill up the burette around 3/4 of the way. Doesn't need to be full right at the 0 marking. For one reason, it's harder to see because it's higher up, but also you're going to have to drain some of the liquid out. And the reason is because the bottom of this burette, the space in here, is accounted for in the actual markings on the burette. So it's designed to deliver this volume, taking into account the space that's in this burette. So before you titrate, you want to make sure that this space is full with the liquid that's in your burette. The other thing that you want to make sure is added before you start is indicator, because you're going to be comparing 2 means of detecting a change in pH. So one way will be the pH electrode itself, and the other will be this indicator called phenolphthalein. And phenolphthalein has the interesting property that when we put it in an acidic solution, it remains clear, but when the solution gets basic, it starts to change color and becomes a really prominent pink color. So we're going to take some phenolphthalein and add about 2 drops to our acid solution. And you only need about 2 to 3 drops. Okay, so now we have everything mixing, and we're ready to start the titration. So before you add anything or you're transferring base at any point, you want to always keep track of initial and final readings on your burette. So one way that you can do this to make it a little bit easier, you can simply just read off of the burette what the measurement is, or if you have trouble seeing it, you can place a sheet of paper behind the burette and then take a reading. And the burette is graduated to about a mil, but the uncertainty on it, remember, is plus or minus 0.05 milliliters. So every reading you take will always have the added uncertainty of plus or minus 0.05. So right now we're at approximately 19 and a half, maybe 19.6 milliliters, okay? And according to the instructions in your manual, the first reading you take is 0 milliliters of base added. So in the Logger Pro software, we're going to click on Collect and wait for the pH reading to remain stable. So looks like it's hovering around 2.22. We'll then click Keep, and then a box will pop up prompting you to enter the volume that you've transferred. Now our first volume that we've transferred is just 0 milliliters, so we would type in 0, then click OK, and the first data point shows up on the graph as well as in the table. So now we're going to add some base. So as we were noting earlier, we're starting at 19.5 roughly, so we're going to now add 2 mils of sodium hydroxide. And to do this, you'll just open the stopcock on the burette until it reaches around 21.5 milliliters. Okay. So again, we wait for the pH reading to stay stable. And when we're content with that, we'll again click Keep. And then again, it asks to enter the volume. So we've added approximately 2 milliliters, so we'll enter that value. Keep in mind that you want to try to put in the exact volume that you've transferred. So even though with mine, I've gone from 19.6 to 21.6, that is exactly 2.0 mils, you'll want to adjust it for yourself. So if it's 19.5 and 21.6, well then you'll want to put 2.01 milliliters transferred. So always keep track of how much you're actually adding. So we'll enter that value into the box here. And there's our second data point listed in both the table and the graph. So now we're going to add the next increment, so another 2 milliliters. And keep in mind that every time you are adding base, it's cumulative. So the total amount of base transferred in your solution is now going to be 4 milliliters rather than 2. So again, check to see what your reading is. So we're hovering around 21.5, 21.6, and we're going to add another 2 milliliters. Okay, so again, check and see where your final reading is at. So we're hovering around 23.5, so which is roughly 2 milliliters. In the Logger Pro software, click Keep again, and then enter the cumulative amount of base that you've transferred. So remember, we've just added an extra 2 milliliters to what we've just added to our beaker. So we're going to add 4 milliliters total. And then the next point is displayed. So you're going to keep adding 2 milliliter increments until you hit, for this titration, around 8 milliliters. And then you're going to want to reduce the increments that you add to your solution. So once you've decreased your increments of base, in this case added to your acid, you should start to see a pink color develop due to the indicator reacting to more basic conditions. So the equivalence point will look a little something like this, where we just start to see that shade of pink, and it's light shade, and then the graph will also sort of indicate to us where we're starting to see the equivalence point in the curve. So then once you've collected your equivalence point, you can then continue with your titration, increasing the increments again until you've completely transferred all of the base that you required. So once you've finished your titration, you'll then hit stop on the Logger Pro software, and you should get a graph that looks something like this. So you'll essentially have a curve that has definitive plateaus on either side and a somewhat vertical area in your curve that will allow you to determine your equivalence point. Make sure that you compare the pH at which the solution turned pink to the actual equivalence point for the particular acid-base system. So in the case of sodium hydroxide and hydrochloric acid, you know that the equivalence point is at pH 7. And so you would use the graph to extrapolate that information. And then carry out various calculations to determine your concentration of your acids and your bases. Make sure that you print screen this graph by selecting Function Print Screen on your laptop and paste it in a Word document so that you can save it and send it to yourself later on. So you'll then repeat this experiment for 2 other titrations. One will be a weak acid, strong base titration, and the other will be for an antacid tablet. Please note that for the antacid tablet, the positions of the acid and base will be reversed. The tablet will be in the beaker, and acid will be put through the burette for that particular titration. And then you'll be able to carry out your calculations later on and determine the concentration of your acids and your base.